Hi there and welcome from Ventura, California to today's webinar, Galileo, at the Dawn of a New Age of GNSS Services, sponsored by Novatel inside GNSS and inside Unmanned Systems, and hosted by WebAttract, the leaders in educational webinars. I'm Lori Dearman, Senior Webinar Producer with WebAttract, and I'll be one of your moderators for today's session. And in just a moment, we'll be introducing our panel of thought leaders, as today's webinar is about hearing from these experts as they discuss what the December 15th Declaration of Galileo Initial Services means for product designers, systems integrators, manufacturers, service providers, and users. You'll also have an opportunity to have your questions answered at midpoint and at the end of the presentation during the Ask the Expert panel session with all four of our panelists today. Now today we've invited you along with over 700 professionals from 57 countries representing a variety of industries. And over the next 90 minutes, regardless of your industry segment or your location, we're confident that you'll find today's webinar of value. But before we get started, Glenn Gibbons, editor and publisher at Inside GNSS, would like to take a moment to welcome you and introduce Demos Gebre-Xavier, who will be moderating the main portion of today's webinar. So over to you, Glenn.
Thank you, Lori. And on behalf of the Inside GNSS team, including our publisher, Richard Fisher, and myself, I want to add our welcome to our international audience for today's web seminar. Last week's declaration of Galileo Initial Services has been particularly satisfying for me. In late 1999, I launched a publication called Galileo's World, which covered the progress of what was then Europe's just-announced program to develop its own global navigation satellite system. After a few years producing the magazine through the early ups and downs of the Galileo program, Richard and I decided that we might have been a little ahead of the market. But we never lost our enthusiasm for the project, and we are delighted to see Europe's perseverance paying off today. We have an excellent panel and set of presentations for you, and they will give you the most current and authoritative information available on the status and plans for Galileo. So now I want to turn the webinar over to today's moderator, Demos Gebre-Xavier. Over the years, Demos has helped develop and moderate many Inside GNSS webinars, and is especially close to today's topic, having just returned from the European Space Agency's Navitec 2016 conference in the Netherlands. In his day job, Demos is on the faculty of the Aerospace Engineering and Mechanics Department at the University of Minnesota, Twin Cities, USA. There, he teaches and researches positioning, navigation, and timing-related issues. His research deals with the use of GNSS in transportation applications and the design of multi-sensor navigation and attitude determination systems for aerospace vehicles. Demos holds a PhD in aeronautics and astronautics from Stanford University. Demos, thank you for joining us again for today's event.
Glenn, thank you very much for that introduction, and welcome everyone out there joining us on this webinar today. Glad you could join us. So to get going, let's start out with a quick poll here. And Lori, if you could bring up the poll question.
Absolutely, yes. Coming up on everyone's screen, you should see the question. As of today, how many Galileo satellites are in orbit? Is it 4, 8, 18, 22, or 26? So it looks like 5% saying 4, 19% saying 8, majority here 63 saying 18, 9% of our audience saying 22, and 4% saying 26. Demos?
Nice spread of answers. And you know what? I will wait for the next speaker to tell you what the answer for that question is. And let me introduce our first panelist who will be answering that question in part. Our first panelist is Marco Lissi, who serves as the GNSS Service Engineering Manager at the European Space Agency in the Directorate of Galileo Program and Navigation-related activities. In this position, he's responsible for engineering and exploitation of services based on the European navigation infrastructures, Galileo and EGNOS, also advises the Executive Director of the European GNSS Agency, GSA. After getting a doctorate in engineering, summa cum laude, at the University of Rome, he worked for more than 30 years in the aerospace and telecommunications sectors, covering managerial positions in R&D, engineering, and programs, both in industry and institutional organizations. Marco, glad you could join us today, and I'm going to turn it over to you.
Okay, thank you, Demos, for your introduction, and hello to everybody in the webinar. My name is Marco Lisi. I work for the European Space Agency, as Demos already introduced. Today I will give you a short introduction to the Galileo system and its present status, just after the initial service declaration. Before doing that, let us watch together the video of the last launch of 4 Galileo satellites on 17th November. Countdown in French. And now you see the Ariane 5 launcher. Now this launch is particularly important in the history of Galileo and of all GNSS systems in general, because for the first time 4 spacecraft were put in orbit all together by an Ariane 5 launcher. A perfect, I would say, beautiful launch, as you can see. All 4 satellites are now reaching their final orbital slots, and they will start soon the commissioning phase. Some basic information about Galileo. Galileo is the European initiative to provide Europe with a highly accurate and autonomous positioning, navigation and timing infrastructure. While being fully autonomous, Galileo will also be interoperable with other existing GNSS, such as GPS. The Galileo system implementation developed in 2 phases, the in-orbit validation or IOV phase and the full operational capability or FOC phase. In its final configuration, the Galileo system will consist of 30 satellites, 24 plus 6 active spare, and of a supporting ground infrastructure. The Galileo system provides a number of services based on different signals in space. The open service and the publicly regulated service are similar, respectively, to the GPS standard positioning service and the GPS precise positioning service. The Galileo-specific commercial service delivers authentication and high-accuracy positioning and timing for commercial applications. The search and rescue service, being part of the COSWAT-SARSAT organization, helps locating people in distress. If you need more information on the carrier frequencies and modulations, this information is available in a slide that is part of the handout of this presentation. Now this slide shows a very top-level view of the Galileo system architecture. The constellation of satellites in orbit is supported on ground by a worldwide network of stations, sensor stations, uplink stations, and TT&C stations, and by a number of centers, all connected by highly reliable, secure, and redundant communication lines. The Galileo ground infrastructure is in fact a large and complex information and communication technology system. The Galileo constellation is similar to the GPS one, but not exactly the same. There will be 24 satellites in orbit, 8 for each of the 3 orbital planes, plus 6 active spare satellites, 2 for each orbital plane. The satellites will orbit around the Earth at an altitude of about 23,000 kilometers. The orbital planes have an inclination of 56 degrees with regard to the equator. This slide gives you an artist's impression of an FOC satellite in orbit. The Galileo satellites are not very big, about 700 kilograms of launch mass. They have a primary power capability of about 2 kilowatts. And they are designed to last 12 years in operation. Visible in the picture are the array of microstrip patches transmitting at L-band, and the smaller array of helices receiving at UHF for the search and rescue mission. The true heart of the Galileo satellites consists of 4 atomic clocks, 2 passive hydrogen masers with a stability of 0.5 nanoseconds in 12 hours that corresponds to 1 second over 3 million years. So far they are the most stable clocks ever flown in space. And 2 rubidium clocks with a stability of 3 seconds over 1 million years. Just for the sake of comparison, a good quality quartz wristwatch has a typical stability of 1 second per year. The next 3 slides summarize the present status of the constellation. A constantly updated situation of the constellation of Galileo satellites is available on the Galileo Service Center website that will be presented later by another speaker. It is worth noting that the 2 satellites put in orbit with the Soyuz launch on the 24th of May this year have completed their commissioning tests and they are fully operational, so they became part of the initial service constellation. The last 4 satellites, launched on the 17th of November, are reaching their final orbital slots to then start the commissioning phase. They should be completed by June next year. They will join the initial service constellation in 2 batches, in April and June next year. The slide shows the past and planned launch schedule. 2 double Soyuz launches with IOB spacecraft in 2011 and 2012. Then 5 double Soyuz launches with FOC spacecraft and the quadruple Ariane 5 launch in November this year, to be followed by 2 more quadruple launches in 2017 and 2018. The Galileo Ground Segment. This slide gives you an idea of the worldwide extension and complexity of the Galileo Ground Segment. Note that the various stations are often placed at very remote sites, at all longitudes and latitudes, and you can imagine the complexity also of the logistics and the maintenance of these remote sites. A number of Galileo centers are spread all over Europe. The European GNSS agency in Prague, that is the headquarters where all services and operations are organized and managed. 2 control centers, one in Italy and one in Germany. 2 low Earth orbit phase centers that gives support after launch in France and Germany. 2 security and PRS centers in England and France. 1 in orbit testing IoT center in Belgium. 1 Galileo Service Center in Spain, an integrated logistics center in Belgium. In this center, a centralized management and all the engineering activities related to the logistics of Galileo, maintenance, spare parts, configuration management, will be performed. And the Galileo reference centers in the Netherlands, meant to provide an independent monitoring of the signal in space quality and of the service KPI, key performance indicators. The slide shows the 2 Galileo control centers, one at Fucino in Italy, top, and one in Oberpfaffenhofen, Germany, bottom. The 2 centers are fully redundant and will control with different primary roles the constellation of satellites and the ground segment. In this slide instead is shown the Galileo Service Center in Madrid. The Galileo Service Center will interface with the world of users and of downstream services and applications. The Search and Rescue Service has got its own dedicated ground segment with the control center in Toulouse and 3 main MIOLAT ground stations, one at the Spitsbergen Island in northern Norway, one at Maspalomas in the Canary Islands, and one in Larnaca in the Cyprus Island. 3 very nice location, either very warm or very cold, I should say. And as you can see, here I have summarized the evolution of the Galileo program. We started with different elements or building blocks, satellites, ground stations, ground centers. Then Galileo evolved into a self-consistent system. Since last week, the Galileo system, surrounded by a service-oriented infrastructure, is able to deliver the initial service to the world. And that's it for now, and thank you for your attention, and back to you, Demos.
Thank you very much, Marco. All right, so moving forward, let me introduce our next panelist, who's Jeremy Godet, who is the head of the sector for the Galileo implementation at the European Commission. Previously, he served as head of security department at the European GNSS agency, GSA, and as the European Commission's security, signal, and frequency team leader on the Galileo program. He was the chairman of the Galileo Signal Task Force, He graduated from the École Nationale Supérieure des Télécommunications in Bretagne, France, and he received his Master's of Science degree from the International Space University. Jeremy?
Thank you, Deimos, for the introduction. And thank you to give me the opportunity to present some details about what Galileo offers during the initial service phase. In October this year, the European Commission presented a new space strategy for Europe, which puts the focus on delivering services and space-based application to everyone's benefits. It fosters competitiveness and innovation of upstream and downstream space industry in Europe. It defines space as a strategic tool for Europe's autonomy, including the autonomous access to space, and promotes international cooperation. Together with the European Earth Observation Programme Copernicus, the European SBAS EGNOS, and of course since last week with the Galileo initial service, Europe is delivering on this vision. Since the 15th of December last week, Galileo offers 3 services. A free of charge worldwide open service, which is fully interoperable with GPS and other GNSS. A public regulated service, the access of which is worldwide but is authorized and controlled by competent authorities in the member states and is for governmental, including security-related use. And finally, a support to search and rescue service under the umbrella of the COSPA-SARSAT organization. It is free and global coverage and allows to locate emergency beacons and communicate the distress to search and rescue centers. In the last 9 months, the infrastructure was thoroughly tested and has shown excellent performances. Using a subset of the constellation, not yet including the 4 satellite launch last November with Ariane 5, and to be precise, 11 satellites for the open service and the PRS, and 12 for the search and rescue, Galileo offers measured 95th percentile performances in the order of 0.8 meters for the ranging average, 3 and 8 meters horizontal and vertical accuracy when associated with a position dilution of precision below 6. It provides better than 10 nanoseconds universal time coordinate reference dissemination and around 7 nanoseconds for GPS Galileo time offset. And finally, a probability of location of a distress within 10 minutes, which is above 98%. The conditions under which the initial services are delivered are described in the service definition documents. These are performance standards, which are defined regardless of any particular applications, and they are based on minimum performance levels. And as more satellites are being commissioned and launched, the performance level will improve and the document will be updated accordingly. The open service and the search and rescue SDD can be downloaded from the GSE website, and I will detail them in the next slides. So this slide is an extract of the open service SDD. As you can see, the minimum performance level consists in accuracy and availability key performance indicators. There is as well information concerning the notice advisory to Galileo users, so-called NAGU, a complementary info published in the GSC website on top of the flags that are directly available to the users through the signal in space. So the open service in this initial phase provides mainly a ranging service and a timing service. The ranging service with an accuracy better than 7 meters for the WERS satellite and 2 meters for the constellation average is interoperable with GPS ranging services, and therefore it provides a direct benefit to users who are able to exploit both Galileo and GPS constellations by increasing the number of available signals in space. The timing service allows users all over the world to very accurately synchronize their clocks to the universal time coordinated reference with an accuracy better than 30 nanoseconds. And on top of it, a precise time offset between the Galileo and GPS system time is provided. This allows users to determine a first position fix by using a mix of, for example, 2 Galileo satellites and 2 GPS satellites. And it is the first time such system time offset is offered by any satellite navigation system on a global basis. Galileo offers from day one multiple frequencies signal equivalent to the GPS Block 3 modernization. There are up to 3 frequencies available for the open service. The E1 frequency, which is the equivalent to GPS L1, E5A, which is the equivalent to GPS L5, and E5B, which is also used by the Chinese Beidou system and in the future by GLONASS. And for the moment, we have one dedicated test signal for the commercial service in the E6 frequency. As such, this is the first open service SDD with a worldwide coverage and multiple frequencies. And there are also 2 frequencies for the PRS. Concerning the Galileo Search and Rescue initial service, it offers a COSPA-SAR-SAT MEO-SAR Ground Segment Early Operational Capability, the EOC, over the SAR Galileo service coverage, as well as a global space component coverage. This initial service was endorsed by COSPA-SAR-SAT Council decision earlier this month, and the MEO-SAR EOC is based on Galileo L-band SAR repeaters on the satellites and GPS S-band experimental repeaters, as well as a number of ground antennas called the MEOLUTs, which are deployed by the various contributing nations. From the EOC to the full operational capability, the evolution will be that we will have a full space segment coverage with the operational L-band SAR repeaters. So this slide is an extract of the Search and Rescue SDD. And as you can see, generally the minimum performance level consists in the probability of detection and location within a certain time and with or without a certain location accuracy. The Galileo SAR minimum performance level are mirroring the COSPA-SAR-SAT MEO-SAR KPIs, except for the detection of or the location time of 10 minutes, which corresponds already to the FOC target, while at the stage of the EOC, COSPA-SAR-SAT only requires 20 minutes. These key performance indicators are available within the Search and Rescue Galileo service coverage, which was earlier described by Marco Lisi, where it is also worth mentioning that the actual measured performance are already above the MEO-SAR FOC targets for all the key performance indicators. So now, Search and Rescue is much faster, from up to 3 hours with the previous LEO-SAR coverage, down to 10 minutes with the new MEO-SAR. And we all know how much time is important when it comes to saving people's lives. It is also now more accurate from 10 kilometers down to 5 kilometers. And all of this is achieved even without changing the existing user equipment on board ships or planes. And actually, just 2 minutes after the start of the operation last week of the French Mission Control Center on the 13th of December, only 2 minutes after, already one alert was detected using the Galileo space segment. And since last week, already 300 alerts were detected and localized using the MEO-SAR. So Galileo Initial Service Declaration is just the first step towards reaching the full operational capability of Galileo by the end of 2020. More satellites remains to be launched to complete the constellation. The new operation contract actually starts tomorrow and aims at ensuring that performance are maintained. We call it the service operator, or the GSOP, and it will be managed by the GSA. In 2018, a number of new service will be introduced. First, the Open Service Navigation Message Authentication, which will provide a digital signature of the open service for increased robustness to spoofing. The commercial service high accuracy, aiming at improving the accuracy of positioning down to centimeters level. And finally, a search and rescue return link, which will acknowledge the reception of the distress to the end users. There will be as well a number of improvements. The open service navigation message will be improved in terms of time to perfect, robustness, synchronization for LBS, using the available spare bits of the navigation message in a fully backward compatible manner. And finally, an action plan will be implemented to facilitate the uptake in the different sectors of the economy and make Galileo available for use in EU policies. Thank you very much, and over to you, Deimos.
Thank you very much, Jeremy. All right, so we will pause at this point and take some questions from our audience for the panelists. And so to do that, let me start off with my first question for, this one will be for you, Marco. And the question is basically, can you tell us something a little bit more about the 18 satellites that are on orbit today that are healthy? Are all of them healthy, or what's the status of their general performance?
Yeah, okay, Deimos. Thank you for the question. So as explained also by Jeremy in his presentation, at the moment, as part of the initial service Constellation, we have 11 satellites for open service and 12 for search and rescue. Why? Because the last 4 satellites are still reaching their orbital slots, so they should not be counted. They will be available next year in June. And the 2 satellites in the past suffered a launch problem, so they were eventually placed on the slightly wrong orbits. And we are not considering them fully operational. We are still investigating about possible uses of those satellites, but at the moment they are not being fully functional. They are perfectly working, but in the wrong orbit, so we do not consider them as part of the initial service. And then out of the remaining 12, 1 satellite has got some problems about some signal space related to open service. So, but the search and rescue payload instead works well. So there are 12 satellites operational for search and rescue, 11 in fact, 11 payloads operational for and part of initial service for open service.
Thank you, Marco. Jeremy, anything you would like to add to that, or do you think Marco got everything you wanted to?
Yeah. We are currently testing the 2 elliptical orbit satellites. As you know, they are used for the search and rescue, and they are part of the initial service for the search and rescue. The tests we are doing are in terms of performance, and the decision will be taken next year whether to use them for the open service. What will be important is that we will not require any specific signal processing in the receiver to make them available. They should be really available in a fully transparent manner as any other satellites if it is decided to go forward.
All right, thank you. This next question is for you, Jeremy, and it's on the positional accuracies that you reported. Is the 3-meter horizontal that you reported, is that in real time, or is that in after some post-processing?
This is real time. This is real time.
Okay. All right, another question. Again, this one I'll start with you, Jeremy, but if the others could chime in afterwards, that's okay. It's and I think the question was asked before got to your slides to answer it, but I'll ask the question regardless. Why only 1 launch each in 2017 and 2018?
Okay,
I guess they're probably talking about the launch of the launches and not satellites per se, but.
So in the last 2 years we launched 12 satellites, so that's an average of 6 satellites per year. And the next 2 years we will launch 4 satellites per year. And at the moment, the 8 remaining satellites to be launched, they are already in the production line. Some of them actually already have been finalized and tested, and some other are in the production. But we don't have currently more than 8 satellites in production. This will depend on a new contract which we are about to sign early next year. And they will come a bit later in 2020 timeframe.
Right. Thanks, Jeremy. Do any of the other panelists want to add anything to this? All right. Let's see, next question. This one is to you, Marco. So in the presentations you and Jeremy made, you indicate that there are going to be different types of services, ground, marine, air. Are there any applications that are space-based that you're aware of where Galileo will be used in the near future? Or can you say anything about the space applications of Galileo?
Thank you. This is a good question, and I like it very much. So it is well known that the GNSS signals can be used for the LEO, MEO, and the GEO satellite orbits, and there have been several studies also to see the feasibility of using Earth GNSS on the Moon. And the reality is that the signal, without using special receivers and special processing, is useful up to 2/3 of the distance between Earth and Moon. Nonetheless, we have been studying at ESA the possibility of using the GNSS in general, Galileo specifically, signals on the Moon to synchronize stations, let's say moon stations, let's put it this way, and to create a local network for navigation and communication. And there was recently a paper of mine presented at Navitec, a workshop here at ESSEC just a few days ago, that was just about this infrastructure on the Moon to support the well-known idea of our Director General, Moon Village. So we are surely studying the possibility of using GNSS also for space applications, LEO, GEO, MEO, and even on the Moon.
All right. Thank you very much for that answer. Let's see, other webinar panelists I haven't introduced you, but Peter, Fiametta, anything you want to say on that? All right. Okay, let's see, and probably we got one more question we could ask before we need to move on, and this one is for you, Jeremy, and the question is the Commission in talks with other governments, say for example the U.S., for access to the publicly regulated service? Can other, say, non-EU countries get access to it?
Yes, they must. The European legal framework offers the possibility to grant access to PRS to non-EU countries, but it is for the Council of the EU to decide whether the conditions to do so are met at the end of the negotiation process. And the Council adopted negotiation mandates earlier this year in July for talks with the United States and with Norway. And the strong interest of the US and Norway to already start negotiation, although Galileo is not yet fully operational, is a very positive sign for us.
All right. So with that, I think we should move on to the second half of our webinar here. So to do that, we'll start with a poll question. Laurie, if you could bring up the second poll question.
Sure. Coming up on the screen is that second question, and we'd like to hear from each of you. Approximately how many major vendors provide Galileo-capable receivers today? Is it 3, 10, 17, 30, or none? So 19% saying 3, majority here 48% saying 10, 18% indicating 17, 13% of our audience said 30, and 2% of our audience said none. Demos, any thoughts on these responses?
Okay, again, as like the first poll question, I think a lot of our audience are going to be surprised. I was when I first realized how many Galileo capable receivers are out there today. And that question will get answered by the presentation of our next panelist, who is Fiammetta Diani. She is the Deputy Head of Market Development at the European GNSS Agency, GSA, where she has worked since 2009. Before joining the GSA, she worked in the private sector for more than 10 years in both aerospace and information technology industries, and gained a lot of experience in the application of space-based technologies for the transport sector. She holds a master's degree in aerospace engineering from Politecnico di Milano and a postgraduate master in economics and business administration of governmental and not-for-profit organizations from the University of Ferrara in Italy. Fiammetta, we're glad you could join us today, and the floor is yours.
Thank you, Demos, for the introduction. So good morning or good evening to our attendees, wherever you are. What I want to tell you about Galileo Initial Services is the point of view of the user. So what the Galileo Initial Services means for the user, and what is the readiness of receivers. That Galileo is ready to use, so we will see some application from smartphones to transport, and also a short outlook on the future and the current R&D opportunities that we can offer for the companies who want to innovate in GNSS and use the differentiators of Galileo. So first of all, let me say that this moment is for us a very important moment. It's a transition moment from the deployment phase to the operational phase, and 2017 will be for us the first year of in which we will be operating Galileo. And my agency is progressively managing this task delegated by the European Commission, while the European Space Agency will continue its role of system designer and development. But what are the initial services for the users? What do they mean? So we heard before that we have an open service, and the first advantage is better availability of satellite signal. So Galileo, in combination with GPS, with which is compatible and interoperable, but also with the other GNSS, will immediately bring more satellites in view, especially in difficult environments like the urban ones, where the satellites may be blocked by buildings. And this will mean for the user a better accuracy in the end. We saw with the presentation of my colleague Jeremy about the improvement of search and rescue. So we go from 3 hours to 10 minutes, and these alerts we received, you can imagine what this means in terms of search and rescue service. If also these come with a better accuracy in terms of position of the beacon in distress. And finally, Galileo will bring also a timing signal. So for the infrastructure that rely on GNSS to be synchronized, and they are in telecommunication, in power distribution, and in banking, the signal of Galileo will be already available from the initial services, because one satellite in view is sufficient to get this signal for the users. But let's not forget that Galileo, since the initial services, will transmit not only on the main frequency E5, but also on a second frequency E5 that is the same of the GPS L5. So this will mean some advantages in terms of accuracy thanks to the ionospheric correction, increased robustness, reducing the vulnerability risk of GNSS signals. And we believe that L5E5 is the second frequency of choice for the future, and we are not alone in this. We were at ION earlier this year with the Broadcom, one major mass market manufacturer, explaining our view and disadvantages. And also E5 for its modulation will bring mitigation of better mitigation of the multipath, and this is one of the local errors that more impact the GNSS, especially for the new applications such as autonomous driving. We used to say that Galileo is a civil system under civil control, but what does it mean in practice? So one of the examples is the GNSS Service Center, the one located in Madrid you heard about before. This is a single interface with the user. We have an help desk that is already operating live, answering questions from manufacturers, from application developers, and also from users about Galileo. We deliver the system status, the notification to the users, and we treat the Galileo incident. And on this, the website of this center, you will find all the documents that have been mentioned and are related to Galileo signal and services. But one of the questions that always I hear, and that was also proposed to you today, is, but can I use Galileo in my receiver today? So at GSA we worked hard in the last years. In fact, you see here that in 2010, so a few years ago, only the three main manufacturers from Europe, STMicro in automotive, U-Blox and Septentrio, maybe because they were morally engaged, they had Galileo. But today, in 2016, 17 major brands of receivers are enabled to Galileo, and they represent 95% of the global supply. So I think this answer to the poll, and I think you should be a bit more optimistic. So let me go to the application. So if these receivers are enabled, in which application we see that they will be embedded. So first of all, we just published a new website. It's called usegalileo.eu, and here we listed all the products that are enabled to Galileo in the different application sectors, so from road to sea, agriculture, and so on. So this is for the user that wants to see what are the products Galileo enabled, but also for the companies that are online today. If your product is not there yet, please contact us, it will be listed. And also it will be updated with all the new products that will come from next year. And we are proud to say that we already have in the market the first European smartphone that is enabled to Galileo. It's BQ Aquarius, and it has on board a Qualcomm chipset, and you can today, after the initial services, already track the Galileo satellites in the smartphone. But Galileo will not go only in smartphone. All the new model of cars that will be sold in Europe from April 2018 will have onboard Galileo. In fact, this is thanks to the emergency call initiative that foresee a box inside every new car that will send emergency call with position in case of accident. And this position will be using also Galileo together with other GNSS. And we are also discussing at United Nations level an harmonization of a different initiative of emergency call, proposing a multi-GNSS solution including Galileo. And it will not go in only in every car, but also in every truck. So this is thanks to digital tachograph. It's a device that improves the road safety, registering the time of driving and rest to respect the EU legislation. This device will not only be enabled to Galileo, but also require increased robustness and trustability. And for this reason, we think it's a typical application for the authentication you heard about that Galileo will be offering in the coming years. And finally, let me quote that Galileo has been recognized by the International Maritime Organization for the use in the regulated vessels, so it can be already used today, and we believe that this will also generate a snowball effect on the small recreational vessels. So let me conclude with an outlook on the future and the R&D opportunities, the research and development opportunities that we can offer. So you heard about the authentication. So the authentication is a differentiator that Galileo will bring, and it's the ability of the system to guarantee to the user that the signal is really coming from the Galileo satellites and not from any other source. It's not spoofed. So we have in mind two kinds of authentication: an authentication for professional users in the form of a spreading code encryption in the frame of the commercial service, and the second authentication that is on the open service, so on the free one, on E1, on the main frequency, and is in the form of a navigation message authentication, so a sort of digital signature of the signal. So this second one, we think it will be really important for all the emerging mobile payment, online gaming, and other applications that make use of the position and want a trusted position. And it will be already available in 2018, so a bit later of the initial services for experimental service, while the other authentication in the frame of the commercial service will come later on. But if you want to know something about the future, we have also recently published our first user technology report. So following the success of the market report, that is a yearly publication of the GSA, we wanted to go inside the receiver and the devices technology to see what is now changing and what will be the innovation in the next decade. So if you want to know something more and you also want to send us your feedback, please have a look to this publication. So finally, as I said, for the companies who want to innovate in GNSS and especially leveraging Galileo, we are managing at GSA on behalf of the European Commission 2 programs for research and development. The first one is Horizon 2020 and is dedicated to application development. And we have today an open call for 33 million euros. The deadline is March 2017, so you are on time to participate and to propose your innovative application that will join the 40 projects that we are already running today. The second program is dedicated to receiver development. It's called Fundamental Elements. We want here to trigger innovative receivers and chipset that address the main market segments and make use of Galileo differentiator. We have an overall envelope of 111 million euro and 7 new calls will be published by the end of next year. So keep a look on our website if you are interested in innovation. So with this I conclude my introduction and I give back the word to Demos.
Thank you, Fiammetta. All right, so let's move on to our final panelist, who is Peter Gronier, who is the CEO of Thales Alenia Space, Leuven in Belgium. In 2000, he co-founded Septentrino Navigation, a designer and manufacturer of GNSS receivers based in Leuven, Belgium, and served as its CEO until 2014. From 1994 to 1998, he was the Science and Technology Counselor for the Embassy of Belgium in the United States. He received an MS in Computer Science and Engineering from the Vrije University in Brussels, Belgium, and an MS in Aeronautics from the California Institute of Technology, Caltech. Peter, I will hand it over to you.
Good morning, good evening everybody. Thanks Demos for the kind introduction. I'd like to start congratulating the Galileo program for this new important milestone, which is the Galileo initial services. I think it's fair to say that we have come a very long way since the first signal reception on January 12, 2006, when the GOVA spacecraft was the only bird in the sky singing Galileo songs. So today there are 18 spacecraft that are orbiting, and we look forward to 4 more spacecraft in 2017, 4 more to be launched in 2018, and another 8 that will become available, as you can see here. As you can see here on this slide. So what you see on the photo is the first waveform that we picked up early 2006, and that was a very important milestone. What I'd like to explain in my presentation is how Galileo initial services respond to current needs in the market, and how they will continue to do so for new needs in the market in a couple of years from now. And I'd like to bring that from a user perspective. I'm a little biased towards the professional user market, but what you can see on this slide is the bipolar simplified view of the user segments. You have the professional segment in the upper right corner. High accuracy, high integrity, high complexity are common for maritime survey, precision agriculture, and integrity is important for aviation users. That represents about 10% of the market. And for mass market users, such as broad and LBS who together represent about 90% of the total GNSS market, the most important criteria are cost, power consumption, size, and not so much the accuracy that is required. So what Galileo does today with this initial phase is really respond very well to more satellites, more signals. So what Galileo does is adding more spacecraft and more frequencies to a very rich set of constellations that allow users to get a very stable and a very precise PVT. And obviously it's not only about Galileo, but there's also the other systems like GPS, GLONASS and Beidou that are adding new capabilities to what we can see in the sky. So that perfectly responds and caters to the needs of today's users. This is made clear on this slide. This was actually recorded in 2014 in an urban canyon. What you can see is the skyscrapers and the four constellations. You see two GPS spacecraft, two Galileo spacecraft, one Beidou and one GLONASS spacecraft. And what they allow you to do is just get a good PVT, which wouldn't be possible with any single system. But moreover, by combining all those systems, you can actually narrow down and reduce the error, which is of importance, obviously, to professional users. There's been more recent tests, like the one that you see on this slide. This is some footage of a recent test campaign conducted over Africa. There was a test flight from Dakar in Senegal to the city of Lomé in Togo on board small aircraft, and the availability of spacecraft was so good that it was possible to calculate the PVT just using Galileo signals. And so with this uncorrected standalone Galileo PVT, we were able to get a positioning error of about 2 meters in the horizontal plane and about 6 meters along the vertical axis, very much in line with the specifications of the system. So this shows you that if you were to combine it with other systems, you would get even better performance. So I've explained that Galileo perfectly replies to the needs in the market today. I believe that tomorrow the user market will become much more complex. So not only accuracy and integrity will be important criteria, but also some sort of protection against spoofing. So authentication will become a third important dimension. And depending on the needs, you will have a professional or a mass market application. And for instance, road, with the rise of intelligent vehicles, you will see that road will have needs in terms of accuracy, in terms of integrity, but certainly also in terms of authentication. It will have to be spoof-proof, because you don't want anybody tamper with the position of your car that drives automatically. So that will become an important feature, and that's what Galileo also will offer. As you can see on the next slide, the spoofing threat has gained recent attention, as you can see in this newspaper article in the Japan Times, and what Galileo will do against that is offer some layers of defense. The open service will be enriched with an authentication message. The commercial service, which will be aimed at professional users, will have a stricter and a stronger level of protection against spoofing, and obviously for authorized users, PRS will be providing protection against spoofing. My guess would be that in the face of those new threats and challenges, other signals and other systems will follow suit to provide protection. And obviously integrity will continue to be a very important feature, and the offering of an integrity monitoring service in the next phase of the Galileo system will obviously be important for users around the world. So this is my brief view on what I believe to be important about Galileo today and tomorrow. And with that, I'll hand over to Demos again. Thank you.
Right. Thank you, Peter. All right. So before we move on to the last Q&A session, let's say a little bit about next steps. The presentation, the webinar that you just saw today, will be available afterwards as a PDF on the Inside GNSS website. The address is given there, and also we've provided contact info for our panelists. So if you have questions or things that you may want to know more about, the contact info is given there. All right, so it's again, thank you very much for all the questions that you're sending in. If we don't get to all of them, we'll try to get to all of them, but I don't think we'll be able to get to all of the questions in the time allotted here. But anyway, so the first one is for you, Fiammetta. It is, are there any plans for transmitting Galileo corrections or providing Galileo corrections on EGNOS?
Okay, thanks for the question. Yes, we are already planning the next generation of EGNOS that will be multi-frequency and multi-constellation, and will correct also Galileo. It will come in the next years, and we are already preparing both the system and the receivers to make use of this capability.
All right. Do Peter or Jeremy or Marco want to add anything to that, or are you... All right. Next question is for Jeremy, and it is I guess one of our audience wants to get a little bit more detail or a little bit more understanding on the high precision services. Can you say a little bit more about that?
Okay, thank you for the question. So the high precision services foreseen in Galileo will be delivered in 2018. It's part of the so-called commercial service. So the principle is that we will send in the E6 message some correction based on precise point positioning. Compared to what is available today on the market, usually you have similar services, but they are delivered using telecommunication satellites, typically links. In that case, the correction will be delivered by the Galileo signals themselves. So there will be a kind of internal feedback in the system. And with the PPP, we can achieve, so the precise point positioning, we can achieve really very good accuracy, a few centimeters level. The question is the time to resolve the ambiguity, so the convergence time. And it looks like, thanks to the multiple frequency nature of Galileo, the convergence time will be really reduced compared to what is available today. So today is about 30 minutes, and we could go down to a couple of minutes to get the initial fix of such accurate position.
Thank you, Jeremy. Marco, anything you want to add to that?
Oh, it's okay.
All right. Next question. This one is for you, Peter. Kind of a general question. I mean, jamming and interference is always an issue for any GNSS. Are there things that are unique or features on Galileo, or I mean, can you say anything about jamming and interference with respect to the Galileo signal?
Well, Protection against jamming obviously is a moving target. It's something that that you have to reply to as it evolves. Obviously, working with more frequencies inherently gives you better protection. But as far as I know, and maybe I should ask this to Marco or Jeremy, there's no special protection foreseen in this respect. But as a general rule, given that there are three frequencies, E1, E5A and E5B, that's obviously a much wider band that has to be jammed if anybody has bad intentions. So inherently that gives you some better protection than what you would have on a single frequency.
Marco, would you have anything you want to add to that?
Yes, I would. I think this is a personal opinion, of course, and I'm open to objections, but Jeremy before mentioned the capability of a commercial service to provide precise point positioning, which is fully true, but I think that we might discover in the future commercial services most interesting in terms of protection against spoofing, because it will be for the first, especially for applications where you need to guarantee timing synchronization secure for critical infrastructures. The commercial services will provide a signal that is encrypted, so intrinsically protected against spoofing. So this is going to be maybe in the future the most interesting feature of Galileo.
Jeremy, anything you want to add to that, or Fiametta?
Yes, I agree with Peter. It takes more resource to jam multiple frequency signals, and I would even add that the signals that are delivered are more powerful. So typically, compared to current GPS signal, minus 160 dB watts, we are now maybe 5 dB above that in L1, and then you add up the E5 signal. So definitely the jammer will need to look bigger. And
Okay.
So we have today all the chipset, the major chipset are ready. Some of them are already embedded in a smartphone you can buy on the market, and an over-the-air update will be available. And all the new smartphone that will come from next year will have this capability on board. So this will be quick because of the replacement rate that we can observe in this field. For what concerns the transportation, probably automotive and road will be the first one to take on board Galileo, and with the eCall initiative I quoted before, we are giving a hand to this process. Probably the one that will take more time are the regulated and standardized transportation applications, such as the train control or the aviation, that will require the time to update all the processes of standard and certification. But that's why we started to work on it even before the Galileo initial services, for example, with IMO recognition and so on.
All right. Next question. This one is for you, Jeremy. And someone noted that in your presentation you said something about SAR services already being used since initial service was declared. Can you say again exactly how many times and what that was used, and if you can say a little bit more about what the occasions were?
Okay. Maybe I will start with the users. Today, there are more than 1.4 million beacons in services around the world, and about half of them are for use in maritime. So basically, any decent ship today, they have a SAR beacon equipped. There are as well aviation users for 25% and land users for the other 25%. So since the initial service declaration last week, actually on the 13th of December, that was at 13 continental time, at the start of the initial service. Just 2 minutes after we got the first distress located, and it was a ship from Singapore, which was actually located offshore of the South African coasts. It was detected by the antenna in Toulouse, and immediately the distress was relayed to the relevant mission control center responsible of the region, which is actually the Australian MCC. So that was the first alert detected, and I think we will try to find the boat and give him a kind of medal for the remembering this important event. And since then, there were about 300 alerts. So in 1 week, 300 alerts were detected and localized using the SAR. For your information, there are about 2,000 people that are rescued every year by the COSPA-SARSAT system. And thanks to this improvement in the system, possibly we will be looking at increasing this number, maybe doubling it every year.
All right, thank you. Next one, this one is for you, Marco. And I mean, well, I guess Marco or Peter. Let's start with Marco, and if Peter has something to add, you could add later on. Now that you've got, I guess, many constellations up there that can provide you a position fix, including Galileo, I mean, how is that done? Is there, does one have to have some sort of, you know, synchronizing between, or is that transparent to the user? Can you say something about having multiple GNSS up there with Galileo now, and how PVT calculations would be done?
Yeah, okay, Demas. Of course, I mean, the receivers, I mean, to take into account the different satellites from different constellations requires some added complexity to the receivers, but take into account that technology progresses so fast that it is very easy to implement these additional features in the receivers. In any case, Galileo in particular is helping the receivers do performing this mix, this melange of different satellites, because for instance, as compared to GPS, we are providing the steering, the time steering between GPS and Galileo satellites. So this would help the receiver in converging and fixing, let's say, taking into account the different time synchronization of the two constellations.
Okay, Peter, anything you want to add to that from the receiver side of the house?
Yeah, so as Marco said, the GPS Galileo time offset is an important feature that helps to converge, and the progress in technology certainly helps there as well. I can say that in my previous life we had a receiver that was capable of tracking the 4 constellations back in 2008 already. So obviously you become better, you become smarter to industrialize it, and but features like the GPS GLONASS time offset certainly help in making it more efficient, and that will help make it more accessible for the user, for the mass market users as well. So we're getting there.
Okay. Anything you want to add to that, Fiametta, perhaps?
Yes, just to say that what was looking like very innovative a few years ago to have a multiple constellation inside the receivers is now state of the art. So also in mass market receiver you have multiple constellation. Now the challenge is power consumption, but I see that most of the device manufacturer and chipset manufacturer, they found a very smart solution also to manage this problem. So it's a reality today.
Okay. Jeremy, anything you want to add to that?
No, thank you.
All right, so related to that, this question is for you, Fiametta. It's, can you say something about the level of market penetration of Galileo ready mobile devices and hardware? In our, is there a lot of them out there, and are they, the ones that are out there, are they backward compatible? Is there a lot of modification that one would have to do to start receiving Galileo services, or what's the state currently?
Yeah, so as I was addressing in my presentation, 17 of the major companies who are delivering chipset, they have Galileo inside already today, so we do expect that the market penetration will grow very fast next year, especially in mass market, because in other segments like in road or in professional is already good today. Can I use my smartphone I bought for this Christmas to use Galileo? It depends on the model. Some model have already Galileo inside today, but it's not activated because they were waiting for us to declare the initial services as we did now. So for some model it's possible an activation over the air, so they send an upgrade of the operating system and you can use Galileo. In other models this is not possible, but it will come very fast in the new models that will be on the market from next year.
Thank you. Peter, anything you want to add from the side of a receiver?
No, thank you.
Okay. All right, let's see. The next question here, I will, this one is for you, Peter, and it is on, you touched a little bit on the integrity being better available, or with Galileo now being an additional GNSS there. Again, can you say anything about? Can you say a little bit more about that aspect? What kind of on the integrity with the GNSS's GPS, Galileo, etc. being available?
Well, you can certainly, if more systems come online and if you can use them to compare PVTs, then that certainly helps in terms of integrity. As was mentioned in Marco's presentation, what was called the Safety of Life Service has been renamed the Integrity Monitoring Service. So once that becomes online, you certainly will get improved in integrity performance. And I would expect that with EGNOS or some of the SBAS systems becoming multi-frequency, that their services will be upgraded as well. So from all the different angles, having more systems that you can combine, having integrity monitoring becoming available on Galileo, and seeing that the SBAS systems are being upgraded, that all is going to contribute to improved integrity performance.
Right. Marco, anything you want to add to that?
No, thank you.
All right. Jeremy?
Yes, maybe a few information regarding this future integrity monitoring services. So there are quite some discussions between the different service provider, in particular with GPS, to provide in the signaling space of Galileo, but as well GPS and other GNSS, some information that will in the future help the receiver to have their own autonomous receiver integrity monitoring. We call it the ARAIM. So the message here is Galileo will push for it, and we will try to do it in full cooperation, international cooperation with all the other providers, so that it is really seamless for the users in a multi-GNSS constellation.
All right. Let's see. Next question. This one is for you, Marco, and it's about the Galileo Constellation. Is the Galileo Constellation such that the coverage of satellites anywhere geographically is even, or is it like other GNSSs that have, I guess, more of a geographic preference in addition to global coverage? Could you say something a little bit more about the Galileo constellation?
Yeah, sure, Demos. The Galileo constellation is conceived to be not to prefer any geographical region. So it is worldwide in its essence. It's similar, very similar from this point of view to the GPS one or the GLONASS one. And so unlike, for instance, the Beidou system, we didn't have any plan to prefer, let's say, Europe. Taking into account, this gives me the opportunity to mention again, it was already done, the fact that Europe took already steps to provide another big important infrastructure, that is EGNOS, to our overall PNT infrastructure. So we have already, since many years, operational EGNOS over Europe, and now we have Galileo that is going to be worldwide, and as mentioned by Fiammetta, the two will somehow further merge together. So the final offer of European offer in terms of PNT to the world is in fact a combination of EGNOS and Galileo. And EGNOS, of course, is at time being focused on Europe, but you know that there are several international cooperations also about that.
All right. This question is for you, Fiammetta, and it is, in one of your slides you mentioned that with Galileo, for time synchronization, all that one needs is one satellite. Can you say a little bit more? I mean, that sounds novel to some that I guess are not familiar with that, and is that the case, and can you say a little bit more how that works?
Okay, yes, so GNSS, GPS, but also other systems, today are used to get the precise timing and not for the position. That was the first aim. And this precise timing is used to synchronize a network, for example, telecommunication network, like the mobile telecommunication network, power distribution ones, and also to timestamp banking transactions and other finance services. And to do this, GNSS is used either as a backup solution or also as a primary source in some cases due to the low cost of the solution. So what I was saying is that Galileo is providing already now this timing. We saw also the good performances observed, presented by my colleague Jeremy. And to have this timing is sufficient to have one satellite in view, while for the position we need at least 4. So Galileo will be used most probably in combination with other GNSS. For timing, we can get the timing from the Galileo satellite. So it can be a valuable backup solution already today to, for example, when GPS is used, Galileo can be a valuable backup immediately from the initial services.
Right, right. All right, again, thank you very much, audience, for all the questions you sent, but we're going to have to stop at this point, and I will hand it over to Lori for some final words here.
Okay, thank you, Demos. And folks, before we sign off, a thank you to each of you for joining us, and trust you found today to be of value. As well, special thanks to our distinguished panel members and, of course, our sponsor, Novatel, and co-hosts Inside GNSS and Inside Unmanned Systems. And again, thanks for joining. This is Lori Dearman saying, hope we see you on the next one. Bye for now.